And we are back. So we're talking about twisted pair. I'm sorry that I had to make an abrupt stop there. Apparently I locked my wife out of the house and had to go let her in. So back to twisted pair where we left off. So again, it's insulated wire. The insulation is also known as sheathing. It's just a plastic coating around your wires. With shielded twisted pair, there's usually a second layer of plastic. I don't have any that I can show you right offhand, unfortunately, but I think we may have some in the classroom, and I'll try and show you guys in class tonight. So, and again, the twists are very important for mitigating the effects of crosstalk and EMI. So more expensive twisted pair is twisted more than less expensive and provides a better pathway for higher bandwidth networks. That's where the different categories come in. Okay, so let's keep going here. Okay, so here is a screenshot of sort of what it looks like. You see that with shielded twisted pair, you've got some additional foil shielding. This is usually aluminum foil. And that's again to help mitigate crosstalk or to help mitigate EMI and crosstalk from other cables. So, but then they also have the sheath there, and sometimes, in fact, a lot of the time, they have plastic, an additional plastic sheathing that's clear plastic around the wire pairs. This is only 2 twisted pairs, so this would be like category, I don't even know, category 1 maybe. This would only be viable for. I guess you could actually use it with, you could use this with up to 100 base TX, but you couldn't really use it for anything else. I guess phones, I suppose. So 100 base TX is what this would be able to be used for. And then this one down here, you've got 4 wire pairs, so this could go up to a gigabit. I don't know exactly, it's not saying what the rating is, but if it's Cat 5e or better, it could go up to a gigabit per second. Okay. So most networks use unshielded twisted pair. 4 pairs of insulated wires. Again, the insulation is just that plastic sheeting around the outside. The categories are defined by TIA and EIA, Telecommunications Industry Association, and Electronic Industries Association. These are just associations or committees that make decisions about standards. These guys would be very smart, much smarter than me. They know a lot about electrical engineering that I don't understand. And also ANSI, American National Standards Institute. So these guys kind of work together. They make decisions together. They're industry leaders. They're comprised of multiple corporation representatives, and they discuss what standards should be. So the categories in the U.S. that are accepted are 1 through 6A. 6A would be capable of your 10 gigabit per second. So when you're asked the question, how fast, what's the fastest that twisted pair, unshielded twisted pair cabling can go, or even shielded twisted pair cabling for that matter, the fastest speed that you would be able to get is 10 gigabit per second. There are 2 additional categories that are not yet accepted in the US, and that is Cat 7 and Cat 7A, and a final category that's not listed here, Cat 8. So there's actually 3 more. But with these additional pairs, they're known as, they're similar to a type of cabling known as twin ax. It's used for very short connections for short haul. Don't worry too much about that, but just be aware of it. But in Cat 7 and 7A and 8, each wire pair is shielded. There's only shielded versions of those. So Cat 5e and Cat 6, and I would say Cat 6A as well, are the most popular types. Cat 5e and 6 are really taking off. 6 is especially common. But Cat 5e is something you can go down to Home Depot and get a box of real cheap. You can get it pretty much anywhere. Cat 6, it's actually becoming a little bit harder to find Cat 5e because of the prominence and decreasing in price of Cat 6. So go figure. But Cat 6 is a very good thing. Market demand, making it less expensive, is definitely a good thing because it's capable of going up to, you know what? No, I don't think Cat 6 is capable of 10 gigabit per second, but it is capable of gigabit speeds. Okay. You see there's different signaling rates for Cat5e. 100 megahertz is the signaling rate. Cat6, in fact, I'm tempted to think that there are different signaling rates even for, so for instance, this shows a signaling rate of 350 megahertz and it's Cat5e. So there are slightly different standards there as far as the specifics on that. I'm not totally positive, but you can take a look at this list. Pretty much everything on this list is accurate. The bandwidth speed up to 1,000 megabits per second or gigabit per second. Bend radius about an inch, which is 4 times the cable diameter. So a quarter of an inch is the cable diameter up to an inch. So bend radius is about like that. So if you were to go around a circle, it would have a 1-inch radius. Okay. And it's the least expensive type of cabling, Cat5e especially. You can get a box of 1,000 feet or more online, especially for about $100. So a 1,000-foot box lasts you a long time, especially when you can only run 328-foot maximum lengths. So you could run 3 of those out of a single box, and it's pretty rare that you ever go that far. Now STP, the whole point of it is it's exactly the same as unshielded twisted pair, except it adds one additional feature, and that would be the shielding. So that foil is designed to help mitigate the effects of EMI on the cabling. It doesn't remove the effects, but it mitigates it significantly enough that you can use it in electronically noisy environments. Okay, so I'll go through these. Oh, this one actually even has the answers, so there you go. You guys get a freebie. You can pause the video and take a look at those. So let's look at the cable plant components. The cable plant is the overall summary of all of the different equipment that is put together in order to run wiring in a business or in a building. So RJ45 connectors are used with twisted pair cabling, either both shielded and unshielded. Your RJ45 connectors need to match the rating of your cabling. If they don't, then they're not going to meet the criteria that your cabling does. And so if you plug them in and expect to get 10 gigabit per second, if you're using Cat6a cabling and Cat5e connectors, you're not going to get your 10 gigabit and in actual throughput. So the data will be transmitted and encoded at that speed, but it will not actually send at that speed. The cabling won't actually manage it. And in some cases it might, but then you might have problems of the cable heating up and stuff like that, and that's never a good thing. So, but RJ45 connectors are very commonly used on the ends of patch cables, which we're going to make some patch cables tonight in class, hopefully. So the term patch cable. Patch cable is used to refer to really any kind of cable that's for running between basically a wall jack and a computer, or a patch panel and a switch port. So we've used patch cables already. Those are straight through patch cables are the ones that we're using. And then there's crossover patch cables, which we'll look at in just a minute. But a patch cable is just a length of Cat5e with RJ45 connectors on either end. That's pretty much it. They also, now oftentimes you'll hear the term patch cable referring to a fiber optic cable, and that is still accurate. It's just obviously fiber optic cable with 2 fiber optic connectors of different sorts and varieties on the ends. So that's a different thing altogether, and you should be able to recognize an Ethernet patch cable, which I guess that's not really an accurate term. Let's say a Cat5e Ethernet patch cable versus a fiber optic Ethernet patch cable. Let's put it that way. So a lot of people want to refer to this as like an Ethernet cable. Throw that out, because Ethernet can use different kinds of cabling, as we've learned just from the networking technologies chapter last time. So in chapter 3 we learned that Ethernet is able to utilize different mediums. So throw out the term Ethernet cable, new term patch cable. Okay, and in fact, to get more specific, twisted pair patch cable or UTP patch cable would be more specific. Okay, And a patch cable can be made relatively inexpensively. We're going to make some tonight, so you will see that process in play. And then you have, as part of your cable plant components, you have patch panels. I wish I had one to demo. We have some in the classroom, and you will work with those tonight. But patch panel is a long strip that has several female RJ45 ends where you plug in your patch cables, and you would plug that in to your switch down underneath. So you would mount that to a distribution rack, also known as a 19-inch rack. You'd mount that, you'd mount your switch, and then you would plug in a patch cable from your patch panel to your switch or hub or whatever interconnecting device. Okay. So you can also mount servers and routers and other things on distribution racks, but they are part of your cable plant. So let's look at, okay, the next slide has some of the info, but let's look at structured cabling. Structured cabling is how an organization should be wired. It doesn't always meet these criteria, but in a perfect world, large networks especially would consist of most or all of these different aspects when you're dealing with your structured cabling. This is how cabling should be organized. So first you have your work area. So let's actually go through these. Work area, horizontal wiring, telecommunications closets, equipment rooms, backbone and vertical wiring, and entrance facilities. So let's look at this. So first of all, your work area. This is where the rubber meets the road. This is where the users are. It consists of a wall jack with a plate, and it consists of a patch cable that connects up to a workstation. So to define it simply, where workstations and other devices are located. So if you have a printer or a workstation or some end device, okay. And of course, base plates, which are the nice prettifying aspect or beautifying aspect of where you put your wall outlets, your wall jacks. A lot of times these get skipped. I can speak firsthand from experience. I've seen a lot of networks in my day, and when IT guys go out and do a lot of wiring, they tend to be a little lazy, I would say, and not do it totally right. So, you know, I don't want to dog on anybody, but I myself am guilty of being a little lazy in some instances. But usually, if you're doing it right, you should have a wall plate with an RJ45 jack in it. This isn't always the case. Sometimes you just have a length of cabling coming out of your wall and plugging directly into your workstation. But if you're doing it right, this is what it should look like. A wall plate with an RJ45 jack, and then a patch cable that plugs in from the workstation to the wall jack. And that is known as a work area. Moving on. Then you have horizontal wiring. Horizontal wiring is what runs in the wall, in the plenum, between the work area, wall jack, and your telecommunications closet. Okay? So from the wall jack to the telecommunications closet. Okay? This is the actual wiring. In this case, you'd want to get CMP cabling. It needs to be plenum rated if it's going in the wall or in the attic or wherever. Okay, if it's going to be behind walls, it needs to be plenum rated. So the rule of thumb on this, okay, I said 10 meters on either end. The actual rule of thumb, I guess, in the lecture is 90 meters for the actual horizontal wiring and no more, because that way you have 10 meters for your work area and 10 meters within your or 5 meters for your work area and 5 meters for your telecommunications closet. About 15 feet on either end. Usually that's more than enough. And then you have a telecommunications closet, otherwise known as a TC. Telecommunications closet is a room, typically, not always, sometimes it's just a little hall closet, literally, where all of your cabling runs to. So it's all sort of coming into that place. So if you have multiple telecommunications closets around a work area, or around in your cable plant, then they're known as intermediate distribution frames. And then you have a central, okay. So in a telecommunications closet, so let me give you a little bit of a distinction here. Telecommunications closet is typically a very small area where you can kind of get into, but and you'll have a distribution rack, a 19-inch rack with patch panel, switches, and whatever else. This would be an intermediate distribution frame. So you can kind of see it here. You've got your work area, horizontal cabling going from your wall plate, wall jack, to the telecommunications closet with an intermediate distribution frame inside that room and a distribution rack. Okay? So then you have equipment rooms, which equipment rooms are a little bit larger generally. It's where you have your main distribution frame. This is where all the intermediate distribution frames connect up together. So if you think about like Yavapai College, you would sort of, our classroom, we don't have a telecommunications closet, but we do have an IDF. It's that rack that's in front of the classroom with all the wires coming into it and making all kinds of noise. That thing then connects up to a main distribution frame in the equipment room for Yavapai College, okay? And so that main distribution frame is sort of the central location for a building that everything connects into, and oftentimes you'll have your connection out to the internet and whatever else. And so the cabling running between IDFs and MDFs is known as backbone cabling or vertical cabling, but backbone is a little bit more common term. So you see here, you've got a couple of IDFs here, right? And those would go to work areas ultimately through horizontal cabling. And then through backbone cabling, you would have a connection to an MDF. This is typically done, backbone cabling is typically done at higher speeds. So fiber optic cabling would be used in cases where the distance is a lot longer or the speed requirements are a lot higher. These can run between floors, wings of a building, and between buildings. So another term for the room that houses your telecommunications, equipment room that houses your telecommunications and connection to third-party telecommunications would be known as an entrance facility. This is where the rubber meets the road. So it's sort of an equipment room with an MDF and routers and modems or whatever else. So this room would also house what's known as a demarcation point. Demarcation point is where your equipment begins and the telecommunications provider communication equipment ends. So if it's your telecommunications provider that leases you a modem or a CSU, DSU, or some other kind of interconnecting device, which we'll talk about different types of devices in Chapter 8, then that would be your demarcation point. That modem, that CSU, DSU, whatever else, whatever, if it's T1 line, CSU, DSU, if it's, fiber optic, different types of things. So that would be housed in your entrance facility, and that particular device would be the demarcation point. That's where they no longer support anything, and it's up to you to make sure everything works past that. They make sure everything works up to there, and you make sure everything works past that. So in other words, it's where the connection to a WAN is made. So installing UTP cabling, we're going to do this in class, but you use a process known as cable termination. This is just putting RJ45 plugs on the end of a cable or punching a cable down into a patch panel. So these are the tools that you use: crimping tools, punch down tool, electrician scissors, cable stripper, cable tester. In fact, this is a screenshot of one of the actual kits that we'll be using because the author actually happens to work in our department, and these are the actual tools that we'll be using to do our terminations. So that's just a sampling of some of the tools that you use, but yeah, that's pretty much enough to do anything. And then you need the RJ45 connectors, and you need your twisted pair cabling. So when you're doing it, you actually sort of straighten out your cables into the correct order. There's two possible orders they can go in: 586A, 586B. 586A was originally developed and patented by AT&T, and the rest of the world said, "Fine, you're gonna make that a problem when we want to manufacture cables." So the rest of the world went ahead and used 586. It's 568. So 568B is the commonly used one. So and that's TIA EIA standards, but again, A was originally patented by AT&T, but it sort of became unpatented at some point when when EIA, TIA sort of stepped in, I guess. But I don't know the exact history on that. I just know that somebody stepped in and said, hey, fine, you want to patent that, we'll just swap around two of the wire pairs. And so really the only difference between the two is the orange wire and the white with orange stripe wire switched with the green and white with green stripe wire. So that's really the only difference in types. But there are some instances where you have to make a different type of cabling. So most of the time when you're terminating a patch cable, making a patch cable, you would use a straight through cable. This means that you use the same standard on both ends, 586B typically. So you would start with the orange white, then you would go to orange, and then green white, and then to blue, and then to blue white, and then to green, then to brown white, and then to brown. Okay, so that's the typical layout, and you would do that on both ends. I don't expect you to have that memorized overnight. I've just done a lot of these, so I know how to do it. But you do that on both ends, and then another type of cable, a special type of cable known as a crossover cable, means you switch the orange and green on one of the ends. Or if it's for a gigabit connection, you would switch the orange with the green and the blue with the brown. Okay, and you would do both pairs. So you would do the orange and white and orange with green and white and green, brown and white with brown, blue and white with blue. So you'd switch them around. So you'll see what that means, I think, a little bit better when we actually do it in a lab. We'll make a crossover cable, but just be aware it's when you switch the two different types. Okay. And the point of this is for media dependent interface. There's two ways that a network interface card can transmit, or a port, I should say. So when data is being encoded onto a line, PCs and routers transmit on 1 and 2. So if we go back, pin 1 and pin 2, so they transmit on, in the case of, let me try not to confuse you guys. So you see 1 and 2 are the transmit pins on MDI, and 3 and 6 are the receive pins. So 3 and 6. So that's why you'd switch 3 white with orange and orange with 1 and 2. And the whole point of this is if one device transmits on 1 and 2 and the other device also transmits on 1 and 2 and you're using a straight through cable, they're going to be transmitting on the same wire. And trying to transmit on the same wire is obviously not going to work, right? You need one end to receive on that same wire. And so when you're going from an MDI device to an MDI-X, or to an MDI device, so from a PC NIC to a router NIC, then you need to use a crossover cable. Now the other thing, the other instance is true as well. So there's MDI-X devices. This is where a device receives on 1 and 2 and transmits on 3 and 6. Okay, hubs and switches do this. So if I'm going between a switch and a switch, I would need to use a crossover cable. Okay, that's the most common instance. Between a hub and a switch and a switch, you need to use a crossover cable. So like devices, MDI to MDI would use a crossover cable. Unlike devices, on the other hand, MDI to MDI-X, so if I'm plugging a router into a switch or a PC into a switch, then I would use a straight through cable. So this is why they're the most common. You don't plug a lot of switches into other switches as much as you plug PCs into switches or switches into routers. Okay, and likewise, you don't plug PCs into router interfaces directly very often, sometimes, but not very often. You usually use a switch interconnecting. Okay, so again, whenever you're using two like devices, two switches, you need to use a crossover cable so that the wires, the transmit and receive wires, get crossed. Okay, that's the whole point. So that's the whole point of a crossover cable. So that's the only instance in which they're used. Okay, so why, you might be wondering, when we look back here, why do we see transmit positive, transmit negative, receive positive, receive negative? The answer to that is differential signal. Differential signal mitigates the effects of crosstalk. Essentially, if you transmit a negative voltage and a positive voltage, it kind of negates the electromagnetic field around those two wires. They sort of cancel each other out. The signal doesn't cancel it out because it's transmitting across the wire itself, but the electromagnetic field that normally would build around that wire gets mitigated down to a very minimal amount. And so they're transmitting at the same time on the opposite, at the same frequency, but on the opposite voltage. So positive voltage, negative voltage. Okay, that's the differential signal. Okay. Don't worry too much about that. If you don't understand the principles of electricity too much, just know that the opposites cancel each other out so that they don't produce a big electromagnetic field around them. Mitigates the effects of crosstalk. At the end of the day, that's the important factor here. Differential signal mitigates the effects of crosstalk. Okay. All right, so let's power through these since we're not in class. You get a freebie on several answers from your test. Okay, so I'm going to stop this video right there. And then we will continue on in the next one.